Hello, dear students. Welcome back to our physics class. So, as you know, in a previous lesson, we stopped at here, question 30 from chapter review. But before solving this question, I would like to give you some brief about the previous question, about the previous lessons. In the previous lessons, we have discussed about the tangential acceleration, which is equal to the instantaneous linear acceleration of an object that directed toward the tangent of the object is motion that moving in a circular path. So the tangential acceleration can be positive and can be negative. In the case of the speeding up, the tangential acceleration becomes positive. So in the case of slowing down, the tangential acceleration becomes negative. So in the case when the object is moving at constant speed in a circular path, the tangential acceleration is equal to 0. Okay, so in this lesson, we will start solving question 30 from chapter review. A very good question. Be careful, okay? A car traveling at 30 meters per second. What is this 30? This is tangential speed, okay? So you can recognize all physical quantity by the units. Meter per second is a unit measured for tangential speed. So which is Vt is equal to 30 meters per second, okay? Undergoes constant negative acceleration. Negative what? Acceleration. So it means that we have reducing of the speed, slowing down, okay? Why? Because the acceleration is negative with a magnitude of 2 meters per second squared. What is this? This is tangential acceleration. How did you know this is tangential acceleration? By the units. Meter per second square is the unit for tangential acceleration, which is AT is equal to negative. Why negative? Because the question said negative acceleration, okay? Which is equal to 2 meters per second square, okay? So when the brakes are applied, in the case when the brakes are applied, it means that this car or this object try to slowing down to reduce the velocity or speed, okay? How many revolutions does each tire make before the car comes to stop? So what is unknown? How many revolutions? So which means that theta in rev is unknown. Okay, what is unknown in this question? The angular displacement in revolution. Okay, because the question says how many revolutions does each tire make before the car comes to stop? What do you mean by comes to stop? It means that V final is equal to 0. So this is V final tangential speed, and this is initial tangential speed. So when V final is 0, omega final of the tire also is equal to 0. Why? Because there is a relation between the tangential speed and angular speed, which is directly proportional to each other. Assuming that the car doesn't skid and that the tire have radius of, what is the radius of the tire? The radius of the tire is 0.3 meter. What is this? This is the radius of the tire is 0.3 meter. Okay? So in that case, we can find the number of revolution. As you know that at first you have to write down the equation. Okay, which equation can be used in this question? You have to think about the full kinematic equation at constant angular acceleration. As you know, in this question, the acceleration is constant, which is equal to negative 2 meters per second squared. So that is why we have to think about the full kinematic equations. Do we have time in this given value in this question? No, because we don't have time. You can choose or select this equation, okay? Which is equal to omega final square, omega initial square, 2 alpha times angular displacement. When does this equation can be used? If in the question the time is not given and not required to find it, okay? When does this equation can be used? When time is not given in the question, not given and not asked us to find it, okay? So, but we have a problem here. So what is the problem in this question? The problem is, do we have omega final? Yes, 0 was given. How did you know omega final 0? Because the question said comes to stop. comes to stop, it means that the tire is stopped. Vt 0. When Vt 0, omega is equal to what? Final omega also equal to 0. Why? Because Vt is equal to omega times r. Okay? And omega is equal to Vt over r. When V is 0, omega also 0. Okay? So do we have omega initial? No, we don't have omega initial, but we can find it. How can you find initial angular speed? Initial angular speed is equal to what? Is equal to Vt initial over r, which is equal to 30 divided by 0.3 is equal to 100 rad per second. Okay? Okay, now we have another problem. Do we have angular acceleration? We don't have angular acceleration. But instead of angular acceleration, we have tangential acceleration. Do we have relation between tangential acceleration and angular acceleration? Yes, of course. As you know, tangential acceleration is equal to alpha r. Alpha is equal to what? Tangential acceleration divided by r. Okay. Do we have tangential acceleration? Yes. Negative 2, 0.3. Alpha, which is equal to what? Negative 6.66 rad per second squared. Okay. Now just replace into the equation. Okay. Now replace. Okay. Omega final 0 is equal to omega initial. We didn't have, but we found it is equal to 100 plus 2 times negative 6.66 times unknown. Okay, so you can rearrange this equation. 0 square is equal to 0, 100 square is equal to 10,000. Take to the other side, it becomes what? Negative 10,000, which is equal to 2 times negative 6.66 is equal to negative 13.33 theta. Okay, theta is equal to what? Negative with negative cancel to each other. Okay, so which is equal to 10,000 divided by 13.33 and is equal to what? 750.2 rad. Okay, but this is not the final of this question. This is not final answer. The question asks it to find what? How many revolutions? So it means that we have to convert this angular displacement in rad to what? To rev. Why? Because the question said how many revolutions. How can you convert rad to rev? We studied. We have to find theta in revolution. Okay, make a fraction. Okay, to find number of revolutions is equal to 1 over what? 1 over 2 pi times theta in rad. Okay, so multiply the angular displacement in rad by which of the following is equal to angular displacement in rev? By 1 over 2 pi. Okay, now replace 1 over 2 pi times angular displacement. We found it is equal to 750.2, which is equal to 119 revolution. It means that this car has 119 revolutions of the tires. Okay, this is very good question. Pay attention, please. So the next topic in this lesson is the centripetal acceleration. Okay, what is the second topic? The centripetal acceleration. After you learned about the tangential acceleration, today's lesson you will learn also about the centripetal acceleration. But before explaining the centripetal acceleration, I would like to tell you something about the velocity. As you know, velocity is a vector quantity. Velocity is a vector quantity which has both magnitude and direction. Okay, such as force and velocity. Okay, We have acceleration, okay? We have many physical quantity, many vector physical quantity, okay? All the vector quantity, they have both direction and magnitude, okay? Velocity has both magnitude and direction. By changing the magnitude of the velocity, okay, changing the magnitude of the velocity, the tangential acceleration is produced. Okay, so when the tangential acceleration is produced, by changing the magnitude of the object. So by changing the direction of the object in a circular path, the centripetal acceleration is produced. Okay, look at this. Let me draw the two figures. Okay, if the object is moving in a circular path, okay, with a varied speed, with what? With a varied speed. What do you mean by varied speed? It means that velocity is not constant. Not constant. The speed is not constant. The speed is changes. Okay. For example, at this point, the magnitude is equal to 5 meters per second. But at this point, okay, at this point, assume that it is velocity, for example, 10 meters per second. Okay, so what happened to the magnitude of the velocity? The magnitude of the velocity changes. So it means that, do we have tangential acceleration? Yes, we have tangential acceleration. Why? Because the magnitude of the velocity changes. Okay, so do we have centripetal acceleration? Yes, already we have centripetal acceleration even at constant speed or in the varied speed. Okay, why? Because the direction of this object is changing. Where is the direction of the object at this point? The object is directed in this direction. At this point, the object is directed at this direction. Okay, so at this point, the direction of the object is directed into this direction. Okay, so that is why the direction of the object, it continuously changes. That is why the object has centripetal acceleration. But why this object has tangential acceleration? Because of changing the magnitude of the speed from 5 to 10. Okay, but when the object is rotating or when object is moving at constant angular speed, okay, okay, so look, for example, here we have 2 meters per second, 2 meters per second, 2 meters per second, also 2, okay? So the speed is constant. The magnitude of the velocity does not change. So because the magnitude of the velocity doesn't change, it means that the tangential acceleration is what? Is 0. Okay? But centripetal acceleration is not equal to 0. We have centripetal acceleration. Why? Because the direction of the object is always continuously changing. Okay? So it continuously changes. At this point, the direction of the tangential speed into this direction. At this point, also changes. Okay, so that is why the object has centripetal acceleration. So we can conclude that the tangential acceleration is produced by changing the magnitude of the velocity. When the magnitude of the velocity changes, such as non-uniform circular motion, the tangential acceleration is produced. And also the object has centripetal acceleration. But when the object moving in a circular path at constant speed, please, don't say constant velocity in a circular path, because the velocity is not constant for the circular path. Why? Even if the speed is constant, because the direction of the object changes. So that is why it's not allowed to say object is moving at constant velocity. The velocity in a circular path, the velocity is not constant in circular path. The velocity changes, but which one changes? Magnitude or direction? The direction of the object changes, not magnitude. Okay, so that is why the object has only centripetal acceleration. Okay. So centripetal acceleration, as you can see in this figure, when a car is moving in a circular path, this car has centripetal acceleration, and sometimes has tangential acceleration, and sometimes has no tangential acceleration, because the tangential acceleration depends on the variation of the speed. Okay, moving a circular path with a constant tangential speed, with constant what? Tangential speed, constant speed, not allowed to say constant velocity. Okay, so with 30 kilometer per hour, so which type of acceleration do we have when the car is moving with constant tangential speed 30 kilometer per hour? We have only centripetal acceleration. We have only what? We have only the centripetal acceleration, okay? Which is directed toward the center, okay? Which is directed toward the center. But in this case, the tangential acceleration is 0. Why? Why tangential acceleration of this car 0? Because the car speed is constant. Constant speed. Constant speed, okay? Even the car moves at constant speed, it still has an acceleration, because the direction of the velocity change in the car, and the car has centripetal acceleration. Okay, what is the definition of centripetal acceleration? The time rate, AC, the time rate of what? Of the variation. Okay, so the time rate of variation of the direction of the velocity when it moves on a circular path. Okay, for example, a car moving in a circular path with a constant speed, so which is equal to what? AC V square over R. Okay, so we can prove this equation, but actually we don't have enough time to prove it. Takes some time to proving this equation. As you know, the direction of the velocity changes continuously, so that is why the object has centripetal acceleration. Okay, in the case when object rotating, okay, for every point or any point on the rotating object has circular motion. For example, this object is rotating in this plane, okay? Any point on this object undergoes what? A circular motion. So that is why, because V is equal to omega R, V squared is equal to what? Omega square R squared. So substituting into this equation, centripetal acceleration is equal to what? Is equal to omega squared R squared over R. R with R cancel. What is remain? Omega squared R is remain. So which is equal to omega squared R. So this equation can be used to find the centripetal acceleration of a point or of any object or any point on the rotating body. Okay, so this is for circular motion, but this is for an object on a rotating body. Okay, so for example, if we have an object and tied at the end of the string and moving or wheeled in the circular path, how can you find the centripetal acceleration of this object? By using this equation. AC is equal to V squared over R. Okay, what is this V? This is tangential speed, because this ball has tangential speed. Okay, so that is why we can use this equation to find the centripetal acceleration, which is provided by the string. Okay, but for rotating object, for object rotating, such as a merry-go or carousel, so to find the centripetal acceleration of the horse on the carousel, you have to use this equation. Why? Because the object has angular speed instead of the tangential speed. Okay, so be careful. For the rotating object, we don't have centripetal acceleration and centripetal force. Okay, so don't say this equation can be used to find the centripetal acceleration for rotating body. This is not for rotating body. This is for what? To find AC of a point on a circular path, on a rotating body, sorry, on a rotating body, okay? So the change in the velocity delta v, which is equal to v final minus v initial, can be determined graphically as shown by the vector triangle in this figure. Note that delta t is very small and v final will be almost parallel to the v initial. Okay, so the vector delta v will be approximately perpendicular to the v final. Delta v, which is what? Perpendicularly to the v final and v initial. Okay, so we'll be pointing toward the center of the circle. Because this acceleration in the direction of the delta v, the acceleration will also be directed toward the center of the circle. Okay, for example, when an object is moving in a circular path, okay, when an object is moving in a circular path, the centripetal acceleration is directed toward the center always. Okay, AC, this is AC, okay? But the tangential acceleration, if the object is moving with a various speed, in the case of the speeding up or slowing down, this is AT, which is perpendicular to the AC, okay? So what is the angle between AT and AC? Is always 90 degree. What is the angle between AT and VT? Is always 0 degree. Theta is equal to 0. Okay? So angular acceleration alpha is produced by what? Angular acceleration by changing the angular speed, which is equal to delta omega per unit of time. But the tangential acceleration AT is produced by changing what? The magnitude of the velocity. The magnitude of what? Of the velocity, delta V over delta T. So centripetal acceleration AC is produced by changing the direction of the velocity. By changing what? The direction of the velocity. Which of the following acceleration is produced by changing the direction of the velocity? Angular acceleration? No. Tangential acceleration? No. Centripetal acceleration? Sorry. Yes. Okay. Prove that AC is equal to omega square R. We prove it already. AC, which is equal to VT square over R. VT, as we studied, is equal to omega times R. Replace into the equation. AC is equal to what? Omega square times R. This equation can be used when the angular speed is given in the question. Okay. So let me ask you a question. For example, when you are sitting at class or at your home, are you accelerated or not? Do you have acceleration when you are sitting on the chair or when you are sitting or when you are at rest? Absolutely yes. Why? Because as you know, we are on the earth and the earth is rotating. Okay? The earth is rotating around itself. Okay? And also the earth is orbiting around the sun. Okay? When the earth orbiting around the sun, which means that the earth is moving in a circular path. The earth has centripetal acceleration. And also we have a centripetal acceleration. Okay? So that is why when we are sitting and when we are at rest, even we are at rest, but we still experience it by an acceleration. So this acceleration is the centripetal acceleration. Okay? So what does the centripetal acceleration depend on? It depends on the square of the angular speed or square of the tangential speed and radius. Okay? Because according to both equations is equal to Vt squared over R omega squared R. Okay? For an object that moving in a circular path, okay, such as this ball when it's moving in a circular path, okay, so what is the relation between centripetal acceleration and the tangential speed? Is directly proportional. Okay, and what is the relation between the centripetal acceleration and the radius of the circular path? It is inversely proportional. Okay, by decreasing the radius, look, by decreasing the radius, what happened to the centripetal acceleration at constant speed? The centripetal acceleration decreases. But in the case by increasing the radius of the circular path, what happened to the centripetal acceleration? The centripetal acceleration is increasing in that case. It is sorry, I do apologize. When we increase the radius of the circular path, what happened to the centripetal acceleration? It decreases. Why? Because it is inversely proportional. AC with the radius of the circular path is inversely proportional. But for object or for a point on the rotating body, the relation between centripetal acceleration and its radius is directly proportional. For example, when this object is rotating, okay? So how can you determine the centripetal acceleration for this object? This object, because it's rotating, has no centripetal acceleration. But the point on the rotating body has centripetal acceleration. For example, if we have 3 points, A, B, and C, okay? And all of the points, they have the tangential speed, okay? So this is VTC, VTB, and VTA. Which one has more tangential speed? The object that farther from the axis of rotation. What is this? This is axis of rotation, okay? Which one has the smallest tangential speed? Point A has the smallest tangential speed. So as I studied in a previous lesson, VC bigger than VB and bigger than VA. Okay, so which one has more radius or distance from the axis of rotation? RC bigger than RB and bigger than RA. To find the centripetal acceleration for each point, for example, for point C, centripetal acceleration for point C is equal to what? Is equal to omega square R. Centripetal acceleration for point B is equal to what? Omega square R. Centripetal acceleration for point A is equal to what? Omega square R. So which one has more angular speed? They have the same angular speeds. Omega A equal to omega B equal to omega C. As I told you, for the rigid body, for what? For the rigid body, all points on the rotating body, they have the same angular speed. They have the same angular displacement. They have the same angular acceleration. Okay? But the value of the linear quantities such as tangential speed and radius and the arc length are different. Okay? In the case when the angular speed is constant, what is relation between centripetal acceleration and radius or distance from the axis of rotation? Is directly proportional. Is what? Is directly proportional. So that is why for rotating object, when the radius increases, the centripetal acceleration also increases. When the radius decreases, the centripetal acceleration also decreases. So which point has the largest centripetal acceleration? AC for point C bigger than AC for point B and B bigger than AC for point A. Okay? But for object, when it's moving in a circular path without rotation, okay? For example, if you have a string and a ball, okay? Assume that this is 5 meters, Okay, the radius of the distance of the string is equal to the radius of the circular path. Okay, so this object has tangential speed. Okay, this object has what? Has tangential speed. How can you determine AC? AC in that case is equal to what? V squared over R. What is the relation between centripetal acceleration and the distance from the axis of rotation? Is inversely proportional. What do you mean by inversely proportional? When R decreases, what happens to the centripetal acceleration? Increases. Okay. Another example. If we decrease the distance from the axis of rotation from 5 meters to, for example, 3 meters, okay, the object still has the tangential speed, and to find the centripetal acceleration is equal to Vt squared over R. Okay, what happened to the distance from the axis of rotation? Decreased or increased? It decreased. Okay, when R decreased, the centripetal acceleration is increased with the same mass and the same speed. Okay, so this is, for example, object A, and this is object B. Which one has more centripetal acceleration? Absolutely, the object AC centripetal acceleration of object B is bigger than AC of object A. Why? Because object B has less radius, less distance from the axis of rotation, so that is why it has more centripetal acceleration. What does the centripetal acceleration depends on? The square of the angular speed, or the square of the tangential speed, and the radius. What are the ways to produce acceleration? In two ways. We can produce acceleration in two ways. The first way, by changing the magnitude of the velocity, which is tangential acceleration, AT. The second way, by changing the direction of the velocity, which is centripetal acceleration, it produces. Okay, AC. Okay, look at this note. For every circular path, the direction of the velocity changes, which is centripetal acceleration is produced. For every circular path, the velocity changes. The velocity is not constant for circular path. Why? Because direction changes. For every circular path, acceleration changes. Why? Because the direction of the centripetal acceleration changes. That is why acceleration changes. In a circular path, the object's acceleration changes continuously. Why? Look. For example, when the object is moving in the circular path, so the centripetal acceleration, is directed into this direction. Okay? When the object reaches at this point, where is the direction of the centripetal acceleration? Toward. Okay? At this point, the direction of the centripetal acceleration is directed into this direction. At this point, at this direction. At this point, this direction. Okay? So that is why the acceleration is not constant. Acceleration changes in a circular path. Acceleration is constant in a circular path? No. The acceleration is not constant. Why? Because even if the magnitude doesn't change, but its direction changes. As you know, for every vector quantity which has both magnitude and direction, when the value of this object changes, the object's acceleration also changes. But also, when the direction changes, also the acceleration cannot be constant. So for every circular motion, the object has a centripetal acceleration due to the variation of its direction. And for every circular path, the direction of the centripetal acceleration always toward the center. Okay? Question 19. Explain the difference between centripetal acceleration and angular acceleration. As you know, as we discussed before, The centripetal acceleration is the acceleration produced due to the variation of the direction of the velocity, which is directed toward the center of the circular path, expressed by meter per second squared. But angular acceleration is the time rate of the variation of the speed, or of the variation of the angular speed, which is measured in rad per second squared. Okay? If an object moves in a circular path, the direction of its velocity changes and centripetal acceleration is produced. And the direction of the tangential speed will be perpendicular to the direction of the centripetal acceleration. So this is very important. What is the angle between VT and AC? Is always perpendicular. Is always what? Is always perpendicular. For example, what is this? This is the direction of AC. And what is this? This is the direction of the tangential speed. Okay? At this point, the same thing. The direction of the centripetal acceleration is also toward the center. So where is the direction of the tangential speed? The tangential speed is directed into this direction. Okay? What is the angle between VT and AC? 90. Between VT and AC, 90. At all points. At all points. Okay? This is VT, even it is 90. Okay? Which means that the angle between them is 90. In a circular motion, AC is inversely proportional to the radius. In a circular motion, when an object is moving in a circular path. But for an object, be careful. For what? For an object on a rotating body, on rotating object, AC is directly proportional. Which is, for the circular motion, AC VT square over R. But for rotating object, for the point on the rotating body is equal to omega square R. This equation can be used for an object on what? Rotating object. Okay? If an object changes its direction and magnitude, the magnitude of the total acceleration is produced. In the case, for example, if you have two acceleration, okay, which is, for example, this object has AC and AT, okay? So because these two vector quantities are perpendicular to each other, and AT and AC is always perpendicular, so that is why we can find or calculate the total acceleration by using the Pythagorean theorem, which is equal to what? AC squared plus AT squared. When does this equation can be used to find the total acceleration? When the object speed is changed, when the speed is not constant, when the speed is varied. In that case, when the object is moving in a circular path with the variance of the speed, this object has both types of acceleration, centripetal acceleration and tangential acceleration. Uniform circular motion is produced when the magnitude of the velocity remains constant but its direction changes. So in that case, A total is equal to AC only has centripetal acceleration. Why? Because A tangential acceleration is 0 in uniform circular motion. But for non-uniform circular motion is produced when both magnitude and direction of the velocity changes, as you can see in this equation. So when does angle equal to 0 between VT and, the angle between VT and AT is equal to 0. Always. The angle between FC and AC is equal to 0, parallel to each other. We will study, inshallah, in the next lesson, okay? So the angle is equal to 90 between what? VT and AC, AT and AC, FC and AT, FC and VT. Okay? VT AC, so this is VT and this is AC perpendicular. AT AC also perpendicular. FC AT, this is FC with AT perpendicular, with VT also perpendicular. Okay? The types of acceleration, so this is repeated, okay? So this is just for Remind you, tangential acceleration formed when tangential speed changes. Centripetal acceleration formed when the direction of the object changes. Angular acceleration formed when the angular speed changes. Gravity for the existence among all material objects in the universe. Okay, and Fg, which is equal to mass times gravity. So this is also measured in meter per second. The forces that exist among all material objects in the universe. An object, we have some ministerial question, be careful. An object is moving in a circular path with a constant speed. With what? With constant speed. What do you mean by constant speed? Which means that the object's tangential acceleration is 0, but AC is not equal to 0. The object has only tangential acceleration? No. Has both VT and AT? Has VT, but has no AT. Has no VT speed? No, this is wrong. Every circular motion has tangential speed. Only has centripetal acceleration? Yes. Okay. Question 2. An object is moving in a circular path, but its speed is not constant. Its speed is not constant. What do you mean by its speed is not constant? It means that when object is moving in a circular path with a various speed, with the varying of the speed, this object has both centripetal acceleration and tangential acceleration. Has both AC and AT. The correct answer is C. Another question. For an object to have centripetal acceleration and no tangential acceleration during its motion, it is necessary. Moves on a straight path? No. On a straight path, we don't have centripetal acceleration. The question says, I'm going to repeat, be careful. An object to have what? Centripetal acceleration, but not tangential acceleration, which means that AC, it has AC, but has no tangential acceleration. Move is on a straight path? No. Move is on a circular path? Yes, but with what? Constant speed. Because move is on a circular path with a various speed is not correct. Why? Because the constant speed has no tangential acceleration. An object is moving in a circular path with a constant speed. Which of the following is correct? Which of the following is not true for this object? An object is moving what? In a circular path at constant speed. It is tangential acceleration is constant. Tangential acceleration is constant? No. It is not constant. Tangential acceleration is 0. Why? Because it's a constant speed. It is centripetal acceleration directed toward the... Sorry, I do apologize. There is something wrong here. I'm going to repeat. This is not, okay? I didn't see this not. Be careful, okay? An object is moving in a circular path with constant speed. Which of the following is not true? Okay? Which of the following is not true? This is not true. No, this is true. The tangential acceleration is constant. Yes, it's constant because constant speed. It is centripetal acceleration is toward. This is also correct. This is okay. We have to find the not true, the wrong. Which one is this wrong statement? A is wrong? No. C is wrong? No. D, the direction of the velocity doesn't change. This is wrong. Be careful. No, this is not correct. The direction of the velocity changes by changing the direction. Okay? As I mentioned before at the beginning of this lesson, velocity has both magnitude and direction. By changing the direction, also the velocity changes. We cannot say constant. When does velocity is constant? When the object is moving on a straight path at constant velocity. But speed, for example, when a car is moving, V initial 10 meter per second to, for example, to east. After a while, a car is reached here at this point. V final 10 meter per second to the east also. So, can we say this object has constant velocity? Yes. Why? Because both magnitude, the magnitude doesn't change, the direction also doesn't change. Be careful. The magnitude doesn't change. The direction of the object also doesn't change. Okay? But when the car is moving, like that, for example, at first, the car, the initial 10 meter per second, again to the east. So when the car is turned into this direction, V final after a while is still 10 meter per second, but at first in this direction, the second time into the direction of the south or down. Okay, so in that case, can we say this is constant velocity? No, this is not constant velocity. This case is not constant velocity. Be careful. This is not constant velocity. Even the magnitude doesn't change. The magnitude changes? No. But the direction changes from east to south. So what we can say in this case, this is not constant velocity, but this is constant speed. This is constant speed. Okay? The tangential acceleration and tangential and centripetal acceleration are perpendicular to each other always. Centripetal and tangential acceleration are not the same. Okay? For an object is moved because the direction of the centripetal acceleration is directed toward the center, but tangential acceleration, the direction is directed to the tangent of the circular path. When an object is moving in a circular path, it always has centripetal acceleration and components of the acceleration because of its direction of the travel, and hence the direction of the velocity is continuously changes. If the object's speed is increasing or decreasing, the object also has tangential component of acceleration, which is tangential acceleration. The tangential component of the acceleration is due to the changing the speed. The centripetal component of the acceleration is due to the changing the direction. To find the total acceleration by using the Pythagorean theorem. As you can see, for example, when the object is moving with the various speed, if the speed is not constant in a circular path, the object experiences both types of acceleration, centripetal acceleration and tangential acceleration. The centripetal acceleration, which is toward the center of the circular path, and the tangential acceleration directed tangent to the object's path. Okay? When both components of the acceleration exist simultaneously, the tangent acceleration is tangent to the circular path, and the centripetal acceleration points toward the center of the circular path. Because these components of acceleration are perpendicular, we can use the Pythagorean theorem to find the total acceleration. Okay, which is perpendicular to each other. For every two vectors that are perpendicular to each other, we can use the Pythagorean theorem. Okay, which is equal to a total AC square plus AT square. Okay, and also we can finding the angle, which is equal to tan inverse AC over AT, opposite over adjacent. Okay, so that's all for today. Hope you enjoy and benefited from my lesson. Inshallah, in the next lesson we will continue and we will finish this section and we will start section 3 in chapter 1. Thank you so much.